Hello and welcome back to my video lesson on derivatives in calculus. In the last clip I talked about the derivatives of 6 trigonometric functions, and now I'm gonna talk about the chain rule. So this chain rule is used to find the derivative of compound functions. And in case you have forgotten, compound functions are basically just a function inside of another function. So just to put it in notation, a compound function is f of g of x. So if you're trying to take the derivative of f of g of x, there's a rule you have to follow. So you just take the derivative of the outside function f evaluated at the inside function g times the derivative of the inside function g, or g of x, g prime of x. This rule, I guess, is kind of hard to grasp at first, but I feel like with practice it becomes really natural and something you'll probably never forget. So just to give an example, I'll use the example I listed earlier about the necessity of the product rule, which is sine of x times x squared. Never mind. I'm stupid. Sine of x squared. Just disregard what I said before. So the outside function is sine of x, and the inside function is x squared. So the first thing you're going to want to do, like I said earlier, is take the derivative of the outside function evaluated at the inside function. So the derivative of sine of x is cosine. So since the inside function is x squared, we, instead of finding the cosine of x like we would do if it was finding the derivative of sine of x, we find its cosine of x squared, and we multiply that by the derivative of this, the inside function, which is 2x. So the derivative of sine of x squared is just 2x cosine of x. Hope you can see that. Yeah. And other times it might be more difficult to tell which function is on the inside. I guess that'd be functions like this. But I haven't taught you the rule for, exponential functions, so I just leave that lingering there. But say if I were to just do this, if you did know, the outside function would be e to the x, and the inside function would be 2x. So the way we would solve this is by finding the derivative of the outside function, or a to the x. So I valued at the inside function, which is 2x, so it would be like that times the derivative of the inside function, which is 2x. The derivative of the inside function 2x, which is just 2. And yeah, there you go. And also you can do chains of more than 2 functions. So you can even use the chain rule if you have something like sine of cosine of tangent of x. Yeah, so that would just be the derivative of the outside function, which is cosine evaluated at the inside function, which is cosine, times tangent of x, multiplied by the derivative of the inside function, which is cosine of tangent of x. So you multiply by negative sine of tangent of x, and you have to find the derivative of the inside function of that inside function. So multiply by the derivative of tangent of x, which is secant squared of x. So yeah, it's a pretty long derivative, but you could even potentially take the derivative of something ridiculous like sine cosine of sine of tangent squared of secant of x with a bunch of parentheses or whatever. And you probably will have to for one of your quizzes, just as a warning. So you should definitely get comfortable with the chain rule. I mean, I guess in like algebra 2 and pre-calculus, compound functions were pretty situational, but that's definitely not the case in calculus. You have to be very familiar and know how to use a chain rule very well. Because like pretty much any any real world application of calculus is gonna have a compound functions, and you're gonna have to use a chain rule. There's just like no getting around it.